So at the very top, you can see we're going to be going over the zero product property and factoring today of quadratics. Our I can statement is I can find these zeros of quadratics. We're going to do that. We're going to be using a thing called the zero product property, which states for every real number a and b, if a times b equals 0, then either a equals 0 or b equals 0, which means that if we have two factors, I'm going to label them a and b just to help recognize that. So if x plus 3 times x plus 2 equals 0, then either one of them has to equal 0. So the idea of the zero product property is based on the idea that if a factor times another factor equals 0, then one of the factors must equal 0 itself. So just some examples using that. So because of this, that means x can have two different answers for when it equals 0 when we have this property. So how we do that is we set each factor equal to 0. So we'll do x plus 5 equals 0, and then we'll have x plus 2 equals 0. And then we solve for x. We solve for this one, we just subtract 5 across both sides. We have x equals negative 5. And for this, we subtract 2 from both sides, and we get x equals negative 2. Both answers are correct. These are the zeros, or the solution set, whatever you want to call them, for a quadratic equation. We're just going to go through a couple more of these examples. So our first step, we're going to set them equal to 0. So, I did hit capture correct. Yes, we are recording. So, I keep writing x when I mean, so we had 6 to both sides. So we get x equals 6. We have x minus 3 equals 0. So x minus 3 equals 0. We add 3 to both sides, and we'll get x equals 3. So it's the same thing for this next one. So we'll have x plus 7 equals 0. Subtract 7 from both sides. X equals negative 7. X minus 2 equals 0. And we add 2 to both sides. X equals 2. So that's our solution. They're zeros. So if x doesn't have anything to add to, we have a solution being x equals 0, because that's our first product, or first factor. And then we have x plus 6 equals 0. So that means x equals 0 and negative 6. It's the same thing for this one, so I'm just going to skip it. When it comes to more complicated things where it's stuff like this, we do the same exact thing. So 2x minus 3 equals 0. We get x by itself, so 2x equals 3. And then we divide by 2, so x equals 3 halves. Same thing for this other one, so 5x plus 2 equals 0. Subtract 2 from both sides. Get 5x equals negative 2. And divide both sides by 5. And you get x equals negative 2/5. Both of these is what the answer is. These are both the zeros.
Good morning. Would you send William Schertzinger to the front of the student office, please?
Will do.
Thank you.
So I want you guys to take the next couple minutes, work through as many of these as you can, and then I will go over them.
fund you. That went to the wrong usually.
Algebra 2, right?
Yeah.
We'll be right back. Work on as much as you can. When I get back, we'll go over them. Alrighty, so let's go over them. So for this first one, you should have got x equals -4 and x equals +8. And then we'll have x equals 0, x equals -2, x equals -1/6, and x equals +7/3. We'll have another x equals 0, x equals +7, x equals 5, and x equals -2/2. Sorry, 2/9. And x equals 0, and x equals 4/3. Anybody have any questions? Not get those answers? Want me to go more into them? Alrighty, so next page. So as we've been doing, we're going to graph, and then we're going to compare our factoring results to see what we get. So we're going to start with our x equals -b/2a, our equation to find our axis of symmetry. So in this, we'll have x equals -6/2. So x equals -3 is our axis of symmetry. So 1, 2, 3. This is our axis of symmetry. When we plug x into our equation, we'll get y equals -3² plus 3 times, I'm going to have to zoom in a little bit for this, plus 6 times -3 plus 8. So this is going to be 9 minus 18 plus 8. So this is going to be y equals -1. So that means our vertex is at the point -3, -1. Then, as most quadratics go, if we go over 1, up 1, that's our next point. We'll find we're at zeros. What we would do is add y plus 1. So we would put x equals 0. Sorry, no. X equals -2 and x equals -4. And when we do, we'll get y equals 0 for both points. So these are our zeros. A way you can do this with Desmos is if you type in your equation, like we have up here, gesture. Type in your equation, and you look at your graph. If you click on your zeros, or where it crosses the x-axis, it'll highlight your points for you. You can also find your vertex this way. But that's how we would have done it when it comes to this. So our first step for this would be to factor our trinomial, which if you remember, using this method. So we'll have, so our a times c is 8, and we need it to add up to positive 6. Factors of 8 that do that are 2 and 4. So then we're going to write them. So we'll have x plus 2 and x plus 4. So our first step is to factor, then we need to set them equal to 0. And then solve each factor. So we did that just like how we did above, so it would be x plus 2 equals 0, x plus 4 equals 0. So that means x is negative 2, and x is negative 4. As we already found in this by graphing, our x-intercepts are x equals, or x-intercepts, so our zeros are at, I keep writing the wrong thing, is at negative 2, 4, or negative 2, 0, and negative 4, 0. How do these answers compare to the ones we found algebraically? They are exactly the same. So you can either factor it or you can graph it and find them. So for these next examples, we're going to be using factoring, and we're going to find our x-intercepts. So we have 1 times 48, negative 48, so we'll have negative 48. That has to add up to negative 8. Factors that add up to negative 8, so one of these are going to be opposite. 48. What factors do we have here? Factors of 48. Oh, we're just going to do it this way. I'm completely blanking on factors of 48. So that's 6 and 8. As you can see, I didn't work these out beforehand. So I'm just going to skip this one for now, because this one's a little easier. If I knew the factors of 48 better, I could do that. Actually, I think 3 and 18. Why is this so difficult right now? Break it up into 30 and 18. Divided by 3, that would be 10 and 6, so 16. Nope, so 4 and 12. There it is, I got it. Negative 48. So we'll have a negative 12 and a positive 4. The reason we found that is factors of 48 of 4 times 12 equals 48. So we'll have x plus 4, x minus 12. And when we solve these, set them equal to 0 and solve them, we'll get our factors to be at x equals negative 4 and at positive 12. Same thing. So negative 6 has to add up to 5. Factors of 6, so that's going to be positive 6 and negative 1. So we have x equals negative, oops. Okay, give me my eraser tool. X equals, or x minus 1 times x plus 6 equals 0. So x equals positive 1 and negative 6. So you'll see for this one, whenever we do this, we have to have it equal to 0 first. So we can put it in standard form, so x squared minus 12x plus 36 equals 0. And then we can set this up. So we have 36 has to add up to negative 12. Factors of 36. We have 3 and 12, 2 and 17? Not 2 and 17. Ooh, 2 and 18. Alright. Because our term here is this, so our signs have to match. So that would be 4. Why am I blanking on math? That's add up to 12. Ignore all of this. It's 6 and 6. Negative 6, negative 6. So that's x minus 6. X minus 6. So when you get both the answers, they are the same. So we'll just have x equals positive 6 as our answer. So then we're going to use factoring and zero product property to solve a binomial with a GCF of x. So first off, we're going to take our GCF out. So we take out our GCF, or we factor out the x. So our will be x times x squared plus x times x plus 4. Equals 0. Set each term equal to 0. And then solve for x. So we'll have x equals 0. That one's already solved. X plus 4 equals 0. We'll have x equals negative 4. Take the next couple minutes to work on these. You should just follow the exact same thing we did up above. And I'll go over the answers once you're done. Oh, that'll take a couple minutes. Alrighty, so follow our steps. Step 1, factor out our GCF, x minus 6, set it equal to 0, and solve each term. So if x equals 0, and x equals 6. So x plus 8, set it equal to 0, x equals 0, and x minus 8. We'll factor out x, so we'll have 2x plus 3, set it equal to 0, and x equals 0, and negative 3 halves. So as you can see, if you can factor out a 0, that means one of your factors is always, if you can factor out an x, that means one of your zeros is at x equals 0. Alrighty, so using factoring and zero product property to solve a quadratic when a is not equal to 1. it's going to be similar to how we did it before. I'm going to first start off by using our trash method. The easiest way, so we first off multiply our first term and our last term, so we have to get up to -6. That has to add up to 5. As we saw before, that is -1 and +6. Yes. So we have -1 and then +6, but because we have that term in the front, we have to write 2x minus 1 and then 2x plus 6. So once we're here, we need to divide one of the terms by our first term. I don't know why it's trying to do this. Divide one factor by our a term or our first term. So in this case, for this one it doesn't work because dividing by 2, we want to make sure that when we do it, the numbers are actual factors of our term. So factors of 6 are 2 and 3. We use our tree. So that means that we can take 2 out of everything. So our factor here is x minus 1, 2x minus 1, and x plus 3. It's a little confusing. And then, same thing as before, we set it equal to 0. We set it equal to 0. And solve for x. So x equals 1/2 and -3. So, another hit. The trick for this. So if we look back up here, you'll notice that our answer was x equals 1/2 and -3. So instead of finding this type of factor form, if we divide everything by our first term. So if we look back, we'd had 2x minus 1 and 2x plus 3 plus 6. Sorry. We divide both things, we'll get x minus 1/2 and x plus 3. This is a more simplified version of our factors. So we get x equals 1/2 and x minus 3. X equals -3. That's our trick is, so these are the correct factors for the actual polynomial. This is a quick way to find your zeros. They're not equivalent. So when you actually take the factor of this is the correct factorization for it. If you divide both of them by your first term, you'll find a quick way to find your zeros. So what we did was we divided everything by 2. So take a second to work on these. I'm going to blank the screen so I can finish working out real quick. here are your answers. I realized that when I did that, I was writing on the board still. So, whatever, you already have your answers. We're going to skip this last one. It's a little complicated. There's a lot of large numbers that I don't have a calculator for. Last but not least, not last but not least, but first off, we're going to factor out our GCF. So for this, we can factor out a 3 from everything. So we'll have x squared minus 4x minus 12. And we can use our normal method. Minus 12 minus 4. We'll have negative 6 and positive 2. So x plus 2, x minus 6. And factor. So we factor out our GCF, factor normally, and then we solve for x. Of x is minus 2 and positive 6. We're going to skip this understanding check just because we're running out of time. I want to give you guys a few minutes to work on your thing, on your practice, and it's basically the same thing we've been doing except with a GCF. So with these, write out a quadratic equation from the description given, then solve. So all we need to do is find out important information. So if x is added to x squared, so we'll have x squared plus x equals 42. How to make it in a quadratic formula and then solve for x, and find our zeros. All we do is subtract the 42 from both sides. So we'll have x squared plus x minus 42 equals 0. And then we can do exactly what we've been doing this whole time. So I'm not going to solve this one out. Same thing over here. So if 3x is subtracted from x squared, so x squared minus 3x. The difference is equal to 10. So to set up the quadratic, we just get everything onto one side. And then we solve like normal. So that's going to be it. If you have any questions, please let me know.